To render a line for a graph, we need some data. We're going to start with some data that's set up specifically for our purposes with an x and a y. It's going to go from 0 and step from 0 to 10 for the x, and each y is going to be stepping by 50. Because our data is set up with x and y's, we're going to set up two selectors. One is going to be an x selector. It's going to receive a data value and return the x. So we're going to say d.x. And then we're going to do a y selector, which will receive a data point and return y. Now this is specific to our data, but if this was like price or anything along those lines, this is where you would return whatever your data is. And now we'll set up our SVG area. So we're going to need to define a specific width and height so that we can scale the data correctly. So we're going to say const width is equal to, say, 500, and the height is going to be equal to 300. And now we can set up our SVG and pass in width, height, and we'll close that, and so we can render something inside of it. Because no data is perfectly set up to render to the screen at a specific pixel coordinate, we need to scale the data to the size of the space that we're rendering. And we use that using scaleLinear. So we're going to say import scaleLinear from D3 scale. Now the first scale we're going to set up is our x scale. So we're going to say const x scale is equal to scaleLinear. And we need to define a range, and that range is going to be the pixel coordinates that we're rendering to. So our range is 0 to our width, because that is the area in which we can render. And then the second piece is our domain, and the domain has to deal with the domain of our data, which also receives an array, and whatever value we place here in the first array slot will map to this value here. So R0 we want to map to the 0 of the rendering. And in our data we can see that our max is 10. So when we render the value 10, we want that value to be placed at our maximum width. So 0 will be mapped to 0. 10 will be mapped to our width of 500. If we were at 5, it would map to 250. So now we need to set up our y scale. So as a const y scale is equal to scaleLinear. And we need to do the same thing. We need to set up our range for our height. So 0 height for our vertical axis. The x will take care of the horizontal. And then we set our data domain, which runs from 0 to 500. So I say 0 to 500. And generally speaking, these are not going to be hard-coded. You might use a min and a max or an extent to grab these, but just for illustration purposes, we'll manually do them. And so this will map from 0 to 0, and 500 will then scale it down. A value of 500 will scale it down to fit within our height of 300. So now that we have our selectors and our scale set up, we can create our line. So we're going to import line from D3 shape. And this will be a line builder for us. So we're going to say const path equals line. And then we need to specify an x and a y. And an x will receive a function, and this line will eventually receive data, loop over each of the data, and call this x function with the data. Now what it expects is a renderable point. So with that, we're going to say x selector, and we're going to pass in our data point, which will then select the x value. And that x value will be whatever is mapped in between this domain, so 0, 1, 2, 3. So that means we need to scale it to our renderable screen coordinates. So we're going to say x scale, and then pass in our x selected value. And then we need to do the same exact thing for our y. So we say dot y, we'll receive the data point, we'll pass that to our y selector, and then we'll scale it to render on the screen in the coordinates that we've set 0 to 300. And finally, this path is a function that will take our data and render the data path. So we're going to say path d equals this path, and we'll pass in our data. We'll need to apply a few other things, so we'll just say a stroke of a tomato color with a stroke width of 3, and we won't have a fill. So we're going to save that, and we can go take a look at a line rendering in our browser. Now, if we inspect this path, we can see here that at 0, we were 0, 0. When we were at 1, we've moved to 50 for the x, and 1 at position 1, 50 for y was scaled to the 30 point. So we can see how that scale was affected, taking our data and turning it into an actual renderable path. Now, when dealing with graphs, typically you will see 0 down here because of the data, but with a SVG, the 0 point for both x and y is here. So in order to fix that, our mapping of our domain to our range needs to flip. So our 0 here for the data needs to map to the height that we can render. So here we flip this around, where 0 will become the height and render in the bottom left corner, and our 500 will be the 0, which will render up here. So if we save this and go back, we can see that it's now rotated where our 0 starts here, but ends up here. Now remember that path that we build up here is just arbitrary. It can take any data. So we can pass in things like some other pieces of data that will map differently. So this down up data goes to the center and then eventually falls back down to a position of 0. So it went up to 250 and then fell back down. We can also switch this back and see how that affects our data. So right, 0 to the center and back. And it also takes other pieces of data. So other functions that will affect how things are rendered. By default, the curve that line sets is curveLinear, meaning it will just basically go to a point. As you can see here, it goes to a point and then goes on to the next path. But if you want something different, you could do something like a curveStep. And to specify that step, you say to a curve, you say curve, and then you just supply the function. So here we've now supplied a curveStep that will affect how it renders. So it doesn't matter necessarily about the data. You can always pass it through more functions that will then eventually affect the render. And finally, when setting this up, you can always adjust the width and height to whatever your constraints are. So if we made this 800 and this height 200, so it was very constrained, we can still see that everything maps and renders correctly into the specific width and height that we've specified, and all the data gets scaled correctly.